Hi everyone, I'm going to do a little video to talk about our lab practical for next week. We had quite a few people absent and I've been asked to kind of provide a little bit of info. So I'm going to do it through video. This is our lab practical assignment page on Canvas, and all of these downloads here are going to be what help you get prepared for it. So just like in class, what I'm going to talk about on this video is what to expect, um, how to prepare, and then what you're going to turn in. Also, I don't know why, but my camera on my laptop is not working, and I live really close to an elementary school, and they are all outside running around screaming today. So sorry about the noise. Sorry about the no video, but we're going to get this done. Okay, so first let's talk about what to expect. When you come into class on Monday, there's going to be a bunch of small flasks up on the counter, and in each of those flasks are going to be two unknowns. One is a neutral compound, and one is an acidic compound, and they're going to be dissolved in ether. And your entire goal by the end of the lab practical is to figure out what each of your unknowns are. So that's big picture. So let's talk smaller picture. What are you going to do to make that happen? So this first document, the one labeled Lab Practical Procedure and Information, this is going to be your most useful tool. It does have some background information. It tells you where to get some more detailed data, or not data, detailed help, detailed procedures. And then it goes into the procedure for our first 3 days. For the first day of the experiment, your job is to separate the neutral compound from the acidic compound. Now, we've done this before. I'm going to go back to our experiment page. Right here, I have experiment A as well. We did experiment A last semester. Experiment 4D is also listed here as something that can help you with this. But the idea is that you're going to use the pH of the solution to be able to separate those two compounds. So by the end of day one, you will have your neutral liquid compound in one flask and your acidic solid compound probably sitting on a watch glass. The procedure that's listed on this handout is giving you the basics. And what I mean by that is it might not give you full details. Like for example, if we scroll down here, on day two, you're going to recrystallize your acidic unknown. Right here, it just says recrystallize the acid. It's not telling you how to do it. It does tell you to choose an appropriate solvent, but it's not telling you how to pick a solvent or what an appropriate solvent is because you've done it before. So this procedure is written in a way to represent the knowledge that you should have at this point. Now, for that recrystallization day for day two, if you need extra information, experiment 3A is where we've done it before. And then on day three, you're going to distill your neutral unknown. And the extra info for that is in experiment number 7. So by the end of day three, you will have recrystallized acidic unknown and distilled neutral unknown. Okay, so we've made it through the first 3 days. We have our separated and purified compounds. Now we need to interpret what they are. So I'm going to scroll down through here. This procedure covers those first 3 days. Now it does say things like run the chemical tests, but again, it's not telling you what they are. So the procedure that's in there covers those first 3 days. Now, you have 12 days to do this lab. So days 4 through 12 are running these tests. If you think you might have a halogen, if you think you have a carboxylic acid, if you think you have an alcohol, you're going to pick one of these tests to do, and based off of the results you get, it will tell you, yes, you have an alcohol, or no, you don't have an alcohol. The procedure for these is in experiment 57 in the book. So I have the book open right here. So here's experiment 57, and I'm just going to scroll down a few pages to get to where we would actually find one of these procedures. This is a very long experiment in our textbook because it covers a lot of different tests. But for example, let me zoom in a little here. Here's the halide section. The first test is called the Bilstein test. So the procedure is approximately a paragraph long. And then after that, it has this discussion section, and that's going to tell you how to interpret those results. The Bilstein test is pretty much putting your chemicals on a wire and then putting that in a Bunsen burner and looking at the color of the flame. And then the discussion will tell you what that color means. And if we look over here, it has the Bilstein listed. It also has silver nitrate listed. It also has sodium iodide. So in that section, the next test, silver nitrate. The next test after that, sodium iodide. So you have the option of doing any of those three tests, or you could do more than one of them. Now, in addition to that, underneath each list of tests, there's a list of known compounds. So these compounds all have a halogen because it's within the halogen section. So you could run one of these tests with a known compound so that you can see what a positive test looks like. We know sometimes that a description can be a little bit difficult to interpret. In a lab, it tells you reacted until it's yellow. And then there's always the questions of, is this yellow? Because it's more orangey or more red or maybe a little bit more green. And you have to decide what yellow means for this lab. These are going to help you make that decision. But you could also go grab cyclohexanone. It doesn't have a halogen, so it would give you a negative test result. So that way you can have a negative result, you could have a positive result, and then you can compare those to yours to see what yours closely matches. So we have all of our tests, all of the known compounds that can be used. So that's what you're going to spend most of your time doing. Before you start these, my suggestion would be to make sure that you get a melting point for your unknown solid, a boiling point for your unknown liquid, and then an IR for both. We know an IR's job is to tell us about functional groups. So once we have an idea from the IR, we can then run the tests to confirm that. Okay, let's see. Let's scroll down a little bit here. I think we've talked about some of this. This is telling you about some of the tests that are required. I'm going to point that out on the report sheet as well, though. Actually, I think that might be where we're headed next. So on this page, the next two things are the report sheets. There's one for the acid and one for the neutral. Let's look at, I have to move my little zoom bar here. Let's look at the acid one first, because the acid one is a little bit more simple compared to the neutral one. So for the acid report sheet, you're going to put a description here: white powder, flaky yellow powder, whatever it might be, your melting point, the solvent you used for recrystallization, your IR data with a reminder to actually attach your IR, your tests. The ones that have stars are required. So you're required to do one halogen test, one nitro test, one unsaturation test, plus a fourth test. So you're required to do at least 4 chemical tests. There's a lot more tests than that. So you'll probably have a lot of blanks on this, which is completely okay. You're going to write the observation here. So we talked about the Bilstein, that we're burning something. So your observation could be a bright yellow flame, and then your conclusion would be positive for bromine, negative for chlorine. Whatever that result means, you're putting that in the conclusion section. And then the last part for this one is your actual unknown. You're going to put the name of it, you're going to draw its structure, and then you're going to defend your answer. How do you know that this is the identity of your unknown? So we're going to look at the one for the neutral. It's almost the same. We have boiling point here instead of melting point because it's going to be a liquid. We have all the tests. The same ones are required. So those first 3 are required plus 1 extra. Now the additional thing that you need to do for your neutral unknown is to make a derivative. So we have 3 derivative options. You're going to do a semicarbazone if you have an aldehyde or ketone, an acetamide if you have an amine, and a 3,5-nitrobenzoate if you have an alcohol or ester. The procedure for these are also in our book. They are in Appendix 2. So procedure for preparing derivatives in the aldehydes and ketones section. The very first one is semicarbazone. So this paragraph is the procedure to turn your aldehyde or your ketone into a semicarbazone. The purpose for this is because boiling points are notoriously inaccurate, and so we turn it into a solid so that we can get a melting point, which is much more accurate. So after you do it, you're going to draw the structure. This is probably just going to require some Googling, and then you're going to list that melting point. So this box right here is definitely bigger than it needs to be, but it's because I have this box here for you to draw that structure in. And then the last page is the same as the acidic. You're going to put the name, the structure, and then your defense for that unknown. All right, so I'm going to close these two because we've talked about both of them. This talks about the derivatives and where to get that information. One of the things here is it says to examine your IR. On the page here, I have a link to the spectral database. This is probably the same one that you used for your take-home test, but it is listed here as well. There's one thing I want to point out. Let's see, agree, there we go. I'm going to just search for a compound. Oh, we will just pick one that's already on here. So I picked heptanal. We're going to look at its IR. This IR was done as a liquid film. We can see that up at the top. If we look over on the left-hand column, there's also an IR done in a tetrachloromethane solution. Sometimes you'll also see Nudilmol or KBR pellet. The liquid film is going to be the closest to what we do for our liquids and our solids. But remember that different concentrations, different temperatures, different quality of machines are going to give slightly different results. And IR's job is to tell us about the functional groups. So try not to expect the IR to give you more than that. We can use it for comparing fingerprint regions, especially if you want to see the difference between heptanal and hexanal. There will be variations, and the fingerprint region can help with that, but it can't be the only thing you rely on because the interpretations online are going to be a little bit different than what we have in class. Okay, there's my little word of advice for that. Let's see, what else do we got to talk about? I think we've done all that. You're going to do melting point or boiling point. You're going to do your IR. You're going to do your required tests and anything else you need to. You're going to make your derivative, and then you're going to, of course, figure out your unknown. Let's talk about what you're going to turn in. So in this next section on here, it's telling you everything you're going to turn in. You're going to turn in the 2 report sheets that we already looked at. You're going to turn in the 2 IRs. So 1 acidic, 1 neutral. And then the 5th thing that you're turning in is a separation chart. We've made these before. We made them last semester as some of our post-lab questions. There's also different techniques in the textbook that will give you some examples of them. I also have a link. The one that's listed here is Tips and Notes website is this one. It's going to give you some information on how to write one. And then honestly, if we just go to Google and type in organic chemistry separation scheme or separation chart, and then you go to images, you're going to see a bunch of examples. So none of these are going to work perfectly, of course, but they're going to give you a lot of information. So like this one, we have a mixture. We're extracting it with 5% NaOH. That breaks it apart into an organic phase, which would be our neutral, and an aqueous phase, which is our acidic. So this is a good way to kind of get started with it. So those are the 5 things you're turning in. I also have rubrics down here for each of the unknown, so one for the acidic and one for the neutral. The acidic is worth 36 points, the neutral is worth 54, and then the chart itself is worth 10. The rubrics, they're over here. If you want to go through them, if you have questions about them, of course, ask. There's the rubric for the acidic. And down here at the bottom, there's these couple extra things. So let's talk about those because it's also listed down here. Sorry, I was trying to decide where to start. Let's talk about the guesses first. You have two unknowns. You get one free guess for each compound. So you've hit day 8. You think you know what your unknown neutral compound is. You come up to me and you tell me it's heptanal. And then I look and I check and I say, yes, that's correct. Good job. Or I say, no, I'm sorry, that's not correct. And then if I tell you no, you go back, you do some more tests, you figure it out. If you want to guess again, it costs 5 points. And this is true for both of them. So you get one free guess for acidic, one free guess for neutral, and then after that, each guess costs 5 points. And it doesn't matter whether you get your guess correct or incorrect. It's 5 points to make the guess. You do not have to guess. Most people will guess until they get it correct, or if they've narrowed it down to 2, then they will guess, and then, they're assuming that if they were incorrect with their guess, then they are assuming they know the other one. It kind of comes down to, are you willing to spend 5 points so that you don't lose more points on your lab report for turning something in wrong? And then the last thing, if you need me to refill your unknown at some point during the lab, it costs 10 points. The reason for this is a lab test, which means that it is testing your lab skills, so to use the chemicals appropriately, but it's also testing your planning process. So you can't just come into class and do every single test that's available just to gather data. You have to come in with a plan so that you're using all of your chemicals efficiently. Okay, so we've talked about what to expect. We've talked about what you're turning in. We've talked about where those points come from. Let's talk about how to get prepared. This can be a daunting lab because there's so much that's going to be happening. So I highly suggest preparing for one day at a time. This separation chart is going to encompass the first 3 days, but mostly day 1. So my biggest suggestion is to treat that as a pre-lab and to figure out your separation chart before you come to class on Tuesday so that you are ready to do that part of the lab. And then before you come into class on Wednesday, have a plan on how you're going to figure out your recrystallization solvent, how you're going to do a recrystallization. And then before you come to class the following Tuesday, how are you going to do a distillation? Come up with a plan, go back and look at experiment 7 if you need to. And then hopefully at the end of day 3, you have a melting point, a boiling point, and your 2 IRs. So then you can come up with a plan for the next couple days on what tests you want to run to either confirm what the IR is telling you or maybe make sense of the IR, because we know there's a lot of different carbonyl peaks. So is that carbonyl peak an aldehyde? Is it a ketone? Is it an ester? Kind of figuring out what those peaks mean. So plan for each day or a couple days at a time. Don't try and plan for the whole lab at once. All right, last question I think we got to talk about is, what are the possible compounds for your unknown? So I'm going to go back to our textbook and I'm going to go to appendix number 1, tables of unknowns and derivatives. Okay, this is going to be intense. All of these pages are your potential unknowns. So it goes on for a while, but hear me out. You're going to get a melting point. you're going to get a boiling point. You're going to get IRs. And then you're going to look at this list and use that information to narrow it down. So let's say from the IR, you figured out you have a ketone. From your boiling point is 180. Now, boiling points aren't great. So with boiling points, we want to give about a plus or minus 15 degrees to assume that it wasn't right on target. So if we get a boiling point of 180, we want to look at everything between 165 and 195. So we take all of those pages knowing that we have a ketone, knowing that we have a boiling point. Oh, I scrolled way too far. Let's try that again. Knowing that we have a ketone and knowing that we have a boiling point between 165 and 195, we can narrow it down to this list right here. So we took those, what, 10 pages or so, and we've narrowed it down to this handful of compounds. And then we look to see how we can separate the rest of these. We do our unsaturation test. We do our halogen test. We do our nitro test, mostly because they're required, but also to see if that helps us separate anything else. Uh, you're also going to do your derivative. So the next column that's on here is the semi-carbazone derivative melting point. And when we look at these possible unknowns, their melting points have a little bit more diversity. So when you get that melting point, you'll be able to cross some of these off the list because the difference between 118 and 244 is really big. So we would be able to narrow it down even further. So you're going to figure out that melting point or boiling point. You're going to figure out your IR, use these tables to help start narrowing it down, and then use those tests and derivative to narrow it down even further. And then when you get to the nitty gritty, when you get to those little details, that might be when you're looking at IR fingerprint regions or you're looking at more specific tests. Oh, one thing I forgot to mention that I want to say is that within some of the tests, so the Lucas reagent test is the one that always comes to mind. The Lucas test tests for alcohols, but it has a different result if you have a primary alcohol, a secondary alcohol, or a tertiary alcohol. So some of the tests get very specific, which can really help you figure out which unknown you have. Okay, I think that's it. Make sure you come to class prepared. This is a test, so you can ask me any questions you want up until when we start. But then after that, I'm going to treat your questions like I would on the day of a test. So I might tell you what to look up or tell you where you should be reading to find an answer, but I'm not really going to be giving you flat out answers. If you're asking me about waste or safety or where to find a chemical, I'll help you with that stuff, of course. But with the actual procedures and how to figure out your unknown, that is on you once the lab starts. If you have questions before we get started, if you want to chat on Monday or Tuesday before class, I would be more than happy to. All right, I hope this helps. And I wish you good luck on finding your unknowns and good luck on getting started with your lab. And thank you.